is an augmented matrix, and that should be 1, -1, 2, 3, -1, 12. When I'm solving this using Gauss-Jordan elimination, you're going to work left to right. So we're going to work in that leftmost column first, and your first step is to make your 1 a 1. So whatever one's there needs to be a 1. It is already a 1, so we don't need to do that step. We're going to move on to the next step. Make everything else 0. So I need to make that 3 0. All I have to do is think about what's the opposite of 3, and that's -3. And we'll take that -3 and multiply that row that we created the 1 or already had a 1 on by that -3. So we're going to do -3 times row 1. We're going to add it to row 2, and that's going to become our new row 2. I have to rewrite row 2 so that I have a 0 there. So that's going to be -3 times the 1 is -3, plus 3 is going to be 0. -3 times that -1 is a +3, minus 1 is going to be 2. And that's going to equal -3 times that 2 is -6. -6 plus 12 is going to be a +6. And we didn't do anything to that first row, so you could have written that first. All right, we're done with column 1. Now we move into column 2. First step when we need to move to a new column is figure out which one needs to be 1. And this 2 needs to become a 1. That 2 needs to become a 1. Well, making 1s is pretty easy because you just multiply by the reciprocal and make sure it's going to become positive if it's negative. So the reciprocal of 2 is 1/2 of row 2. Becomes my new row 2. Well, I didn't do anything to the first row. That's why I circle what I'm going to work with. My bottom row is 1/2 of 0 is 0, 1/2 of 2 is 1, 1/2 of 6 is 3. The last thing I need to do is find all the zeros in that column. The only one that needs to be a 0 is right there. The opposite of -1 is a +1, so I'm going to multiply row 2 by +1, but really that's just saying 1 times row 1, or just 2, plus row 1 is going to become my new row 1. I'm just going to add this row straight to that row. And that's going to be, so we have 0 plus 1 is still 1. 1 plus a -1 is 0. 3 plus 2 is 5. And the bottom row stayed the same. I didn't circle anything in there or say I'm going to change anything. I have my identity matrix. I got a row of 1s. Everything else is 0. So that means that x, this row tells me x equals 5. This row tells me y equals 3. Questions, comments, concerns? All right. Today, our calculator is going to do all of our heavy lifting for us. So let's go ahead and take out our calculators. I have my calculator already up on the screen. And we are just going to do Gauss-Jordan elimination using our calculator. Now, our calculator can solve things in different ways. All right, this is specifically using Gauss-Jordan. You will see we're going to use our calculator to come up with that identity matrix. You will see the identity matrix. It will actually show it to you when we are done. Just be aware there's times we're going to use inverses to solve it. If I tell you to use one method, you have to show me, I'll make sure on the test, I'm like, show me your identity matrix so I know you did this. Make sure you're going to know both methods to use your calculator. In this one, we're just going to use Gauss-Jordan. Does anyone have a Casio calculator? Cool. That makes my life a little easier. All right, we're going to use our TI-80, whatever you have, to solve this system of linear equations. Cool thing is, up until now, you probably didn't know how to use your calculator to solve a system of linear equations. It probably would have made your life a lot easier. So, in order to use our TI to do that 2x plus y equals 4, I know I didn't give you a ton of room, but you need to realize that we need this in matrix form for our calculators. So the matrix form of this would be 2 1 equals 4, 4, 2, and 8. And in short, you're going to plug this in your calculator, and you're going to tell your calculator to solve it for you. So we have 2, 1, 4 in the top row, 4, 2, 8 on the bottom row. Let's go through this together. You have step-by-step guides on there, but we'll do it by hand. So the big thing we need to know is where our matrix button is. Our matrix button is right above our, let me put this down. I think I have this set up, so it'll work. All right. Is it on? All right, so you're going to hit second matrix. And that doesn't seem to be on. Oh, there we go. So we're just going to hit second, and then X to the negative or inverse button is going to be your matrix. If I hit enter right now, you're going to get a big A on your screen. You need to go all the way over to edit. And at the very top, it's going to ask for the size of your matrix. You need to know how many rows and how many columns you have. Just so happens that I have it in correctly. We have 2 rows and 3 columns. Even though we have a line on there, the calculator is not going to have that augmented. You're just going to have to do a 2 by 3 matrix to fit all our numbers in. And you can hit enter to keep going. And in your top row, you are just going to, I want to make sure this is still right in there. You are going to enter your 2, and you're going to hit enter. You're going to hit your 1, hit enter, 4, enter, and it'll go down to the next row. 4, enter, 2, enter, and finally 8, enter. So that matrix should look like the one we just drew on our sheet, correct? Minus that bar. Are we all good? We got that?
Yeah. Is that the right answer?
Yes. Yeah. All right, now we're going to back out of here. And we're going to go back to that matrix menu. So you're going to hit second, matrix. Now we're going to go over to math. Math is where we calculate all the stuff with our matrices. Here's where it gets a little tricky. They use a different term for it than like identity or Gauss-Jordan elimination. They're going to use something called RREF. It's called reduced row echelon form. That is the official term to put something like this in your identity matrix. This is officially putting in Gauss-Jordan elimination. So reduced row echelon form is the one you're going to use. RREF. It gets confusing because there's an REF above it. You will know if you did it correct in just a second. So we want to use RREF. And you're going to go ahead and hit enter. Now we have to tell it what matrix I want to do the reduced row echelon form of, because we can put multiple matrices in here. So we're going to go back to our matrix. This is going to allow us to choose which one we're going to work with. I only have one of these in, so I'm just going to go ahead and hit enter because I know it is the A one, and you should see reduced row echelon form of matrix A. And then you're just going to hit enter again. Now that should come up with your identity matrix where you have 1s and 0s. Did this come up with 1s and 0s? It's close. What type of problem is this? If it has 0s all the way across the lines. It's a dependent because we have 0 equals 0. So quick as that, you know that this is a dependent matrix or system of equations. Any questions on that? Yes?
Is there a way we can bind the RREF function to 1 so I can just click 1?
So you click, probably depends on your calculator.
Well, I assume so. I can just look for it.
Yeah. I assume there is a way. I've never done it.
That'd be a lot easier than scroll.
Yeah. But it's a number. Also, it's a number. So a quick way to do it, because Joe just brought up, because it kind of, you have to scroll all the way down, Joe. This is a great way to do it. If you go to second matrix, and you go to your math button, but no, hang on. Second matrix, and you go to your math button. If you look at each one of these has a number on it. What am I doing?
So that's B.
So you just have to do your B button, which is, you should just be able to do alpha B.
Yeah, Try to make it easier than that.
Okay, yeah. So it is 2 keystrokes to get to it. So if you want to speed stuff up, you can do your matrix, go to math, and just remember in a second. Most of the time in the real world, you won't be doing 50 of these problems at once. It'll be like the SAT where you just have to do like one quick one. So scroll down and get it. Any questions on that? I'll be around to help. All right, go ahead and get started. Otherwise, does anyone have questions from the homework? Because we can go over those right now too. Questions from the homework going once? Questions from the homework going twice? All right, go ahead and work on that stuff.